Okay.
Huh? I was taking pictures.
Sure. Okay, here we go. 2-8, that's what we're going to cover today, and it is solving for a specific variable. Okay, so I want to mention 4 specific cases that I want to bring up today to show you, and that will hopefully help cover about 80 to 90% of the problem that you will see, which still going to help you a lot. Okay. But before we start with this concept, I want to remind you a little bit here that when we're solving for an equation that has a specific variable, what is our end result? What do we want the end to look like? Okay, for example, if I have this particular equation, for example, okay, what is it? This is the before picture. What is our ending picture should look like to know that we are done? Okay, so the x has to equal something, but and x is isolated. Is that true? So our end result is we want the variable that we want to solve, or we target, by itself on one side. Okay, so that's the first step. And now I want to bring back a little bit here. If we are solving for x, we need to get rid of the 3 and the 2. Is that true? The 3 is considered to be a term or part of a term. Look at the 3. How do we know it's a term? It's separated by a plus or a minus. Remember that one? So 3 is a term. How do we get rid of a term?
The opposite of what the term says.
There are only 2 operations. What 2 operations we call adding and subtracting. So in other words, if we are removing an entire term, we have 2 options. Either add it or subtract it over. And I hope that kind of reminds you that, hey, look, a term is separated also by adding and subtracting. How is it, you see? Do you see the link here? That your terms are separated by either adding or subtracting, so therefore we are also using addition or subtraction to remove the term. I hope that's clear. And then I also mentioned about the coefficient, or what we say, part of a term. And how do we get rid of part of a term? We either divide or multiply. And why does it look like that? Look at the 2. That's part of the term. What's linking the 2 to the x? What operation is linking the 2 to the x? Multiplying. So therefore the opposite of multiplying is dividing. And one other thing that I need to remind yourself of always is this. I hope you remember this. Yes, but like this. Backwards. That means we always take care of our addition, subtraction, multiplication, division, and then our exponent and our parenthesis will be the last thing we cover. Okay? Are we clear before we start? Okay, so we know I cover the basic ground rules with you, so this is like a game really. I gave you the basic rules. Now let's get it on. Alright. Are you ready, guys? Let's get it on. Alright, here we go.
It's not recording it.
First scenario. First scenario is actually an easy scenario. Let's say I have here 8x plus by equals to c. Okay, fine. You look at this and like, Mr. Nguyen, what the heck is that? Right? I'm like,
What the heck is that?
okay, so and then you probably say, wait, what variable are we trying to solve for this time? Before I only have 1 to care about, I have 1, 2, 3, 4, 5 different variables. Which one are we solving for? Well, this is why this lesson is called solving for a specific variable, because I will specify which variable I want you to solve. So here it is. I want you to solve for, listen carefully, y. I want you to solve for y. So that means that all eyes should be on y. So that means, so this is like before and after photos, This is me all fat and bulky, and now I want to trim all the fat, excess fat. That means I have to trim away the AX, right? And I also need to trim away the B to achieve the look. Look at that. I want Y by itself, isn't it? That's what I want, though. See, if you can actually see the before and after picture, you know exactly what to get rid of. I need to get rid of AX, and AX is considered to be one whole term or part of a term? One whole term. So I need to get rid of that one whole term. What about the B? Is that one whole term or part of a term? Part, because BY is considered to be what? Yes?
Wait, why is A and X, the whole thing.
Okay, what's linking A and X together? Do you say 8x or do you say 8 times x?
8 times X.
And is that linking together by times?
Yeah.
And did I say that the terms are separated by either adding or subtracting, not by multiplying? So when you have, look, it's like this. Pretend your A is like 5. Isn't 5x a term?
Technically.
Yeah, that's why. Okay? Anything that's linked by a multiplication sign, I don't care how many variables you see after that, that is still one whole term. But as soon as you see like a plus, something else, that's 2 terms. You see the difference? Okay? So let's go back to this again. AX is a whole term. Now look at B. I want to get rid of B, and B is just a part of a term. Because BY is the whole term. You see it? And I don't want to get rid of Y, I just want to get rid of B. So that's part of a term. So I need to get rid of AX and B. So let's take a look.
Oh.
Did I just do that?
I
I just did that. Okay, fine. Solve it for Y. Alright. What do I need to get rid of first? Good. Things that are farther away should be the first to go. Should I talk about the relationship problem again? You know that right now. So, how do I get rid of AX? Minus it over, because it is entire term. So minus it over, and I will have B times Y equals to C minus 8x. Notice I can't do anything about this, so I leave it as is. How do I solve for Y now?
Divide.
There you go, because B is a part of a term. To get rid of it, I do the opposite operation, so I divide both sides. And so, my final result
C equals.
is Y equals to that. And I am done. I just solved for a specific variable.
That is crazy.
That's it.
It's gonna be hard.
Huh?
It's gonna be hard to see.
Okay, but are we clear on this part so far? Okay, so that's the first scenario where everything is actually quite easy. You move the entire term over by adding, subtracting. You remove part of the term by dividing or multiplying. So just remember that basic concept. Now here's the next scenario that I want to bring up. Scary. Okay, here's the second scenario. This second scenario involves your variable that you want to solve for lives right outside the parentheses. Okay, so for example, I have AY times BX plus CD equals to Z. And I want you to solve for Y. Okay, do you see your target variable yet? Okay, so if that's my target variable, I'm going to go ahead and just kind of underline it, mark it, whatever it is that you need to do to indicate that, hey, that's what I want to stay. It's not going to go anywhere. I'm holding on to it. The rest has to go. What has to go?
plus CD.
Okay, so notice that BX plus CD is in parentheses. It's one group. So that means when you get rid of it, you have to get rid of the entire group at once. You cannot, remember, this is one group, so when it goes as a group. You cannot separate it. It's inside parentheses. And then so you ask yourself, what is linking the parentheses to the Y?
Multiplying.
Good, so what is the opposite of multiplying?
Divide.
Oh, there you go. So that means to get rid of it, I divide. Done.
Crazy.
Do you see that? So now my equation looks like this. Was that bad? That's not bad, right? How do I solve for Y now? Oh, divide by A. But you know that when you divide by A here, you're going to have to find the reciprocal stuff. So can we just start with the reciprocal already?
Yeah.
What is the reciprocal of A?
1A.
1 over A. See that? 1 over A. So this is gone. Y now equals to, if you multiply across, it's going to be Z on top. It's going to be A times BX plus CD in the bottom. And there you have it, sir. That's how you solve for a variable with involving parentheses.
You're going too fast. You're going too fast.
Okay.
What's hard?
Let's just slow down a little bit. I'm sorry. Shh, listen. Listen carefully. Did you get the part on how I get rid of the BX plus CD?
Yes.
What'd you say?
Did you get this part on how I got rid of BX plus CD?
Yeah.
Okay, who said no? Okay, why? What happened? Okay, first of all, let me ask you this question, okay? Let me just kind of set this aside for a moment. I'm not trying to make it difficult, but look. When I get this done, you'll probably understand it better. But watch. What if I write it in another way? Listen. Pretend that A is your 2, okay? Y is still here. And pretend that BX right there is like your 5, and then CD is like your 7. And over here is like your 8. You see the difference now? Before, you can actually combine 5 plus 7 together, it's 12, right? But here, we cannot do that. We have to leave it as is. But even if you combine it here, for example, if you want to get rid of 12, don't you divide it by 12 both sides?
Yes.
And that's what I'm doing here. Inside parentheses, I treat it as one group. So when I want to get rid of that group, I divide that whole group over. Just like what I'm doing over here. Okay? Why am I dividing? Because notice that A, how does A link to Y? It's multiplying. And how does Y link to the parentheses? It's also multiplying. So the only opposite operation that for multiplication is dividing. That's why I divide. And don't forget, the mentality is if it's inside the parentheses, it is treated as one whole, one group. If you are to get rid of it, you have to get rid of it all at once. So if it's that confusing to you, I would highly suggest that you do something like this. Rewrite it. AY here, and then this whole group right there, BX plus CD, just think of it as one big B. That big B represents this right there. Now, does it look better? How do I solve for Y? Don't you have to get rid of B first? How do I get rid of B? I divide by big B, which is the same thing like I divide that. You see how it works? That's what I'm doing. Okay, is that clear? Okay. And so now, look, there it is. Pretend that big B is BX plus CD. That's what I'm saying. So now you have AY equals to Z over big B. And how do I solve for Y? Do I need to divide by A? Right? Fine, let's do it this way. You like it that way then? See? You still have to times it by the reciprocal. You see how that works?
Yeah.
There. And so that's my end result. I'm multiplying by reciprocal. What do you think of BX plus CD? That's like a big B right there. Okay. Okay. That's what it looks like. Okay? Let's look at our third case. Perhaps I'll make a clearer case when we see this here. Look at your third case. Still involving parentheses. I have here, let's put in the numbers for you to comfort you a little bit. This is Z, by the way. Okay, let's say that. I still want you to solve for Y again. So where's my target? Right there, isn't it? But this time around, it lives inside the parentheses. You know that inside parentheses, we cannot touch it at all. What's holding the parentheses there? The term outside of it. Notice that if I get rid of big 3x, can you get rid of the parentheses then?
Yeah.
You see it? So you gotta remember some basic ground rules. The reason the parentheses is still there because I have a term in front of it. If I get rid of the term in front of it, the parentheses will automatically disappear. So your job now is to get rid of the 3x. How do I get rid of 3x? See? Why are you dividing instead of multiplying? Because what's linking this to the parentheses? Multiplication. So the opposite of multiplication is dividing. You see it? So if I divide both sides by 3x, you now will have y plus z equals to d over 3x. And notice that my parentheses disappeared because there's nothing holding it in place anymore. Think of your term outside of parentheses, it's like a power supplies to this force field. Now if I take that away, it can't sustain, right? So it will be gone. So how do I solve for y now?
Minus Z.
There, see, because z is considered to be a term. To get rid of the term, I do the opposite of that plus sign, which is minus z over. So then y now equals to z over 3x minus z. And I complete my thing there. Question on that?
How would we do this in real life though?
Oh yeah.
How do you use it in real life?
How do we do
Okay.
that?
Can we get this done first?
Okay.
Okay.
It's kind of hard though.
Okay, are we cool with this so far?
Yes.
Alright, move on. Take a look at number 4. Here's the fourth scenario. The fourth scenario involves the variable that you want to solve for lives on both sides, or maybe you have multiple variables at the same time. So for example, I have bx plus 3a equals to wz minus cx. Okay, there it is. And I want you to solve for x. So this time around, it's kind of hard this time because I want my x to be alone by itself on one side, but notice I have x over here and x over here. They're all separated. So when you see that case, first priority is to put them all together one side first. How do I move this over? Just like before. How do I move that entire term over? Add it. So I add the cx over.
It's a happy face.
So it will look like this. Is that true? I just moved the cx over. Okay.
Wait, can you explain it again?
Okay. First of all, I need to have all the variables on one side, right? The variable that I want to solve for. Is that true? They're isolated. Not isolated yet, but they're both one on each side. I need to put them all together on one side. So I need to move the cx term over.
Wait, but can you move the
bx over?
Yeah.
Yeah, you can. Do either way is fine. I don't really care. The reason I'm choosing cx is because I want to turn this into a positive. See it? But if you move bx over, you have to subtract bx over. So either way. Okay, now, if I want my x to be isolated, really, I also need to move the 3a away. Is that true?
Yes.
How do I move the 3a away?
Subtract.
Subtract 3a away. So notice I'm moving the terms over. So now my next step is going to look like this. bx plus cx equals to wz minus 3a. I'm almost there. I can practically taste our finish, right? However, I'm like, wait, I have two x's. I can only allow to have one x. How do we combine them together or absorb them into one? Yes?
B plus C parentheses X.
Ah, notice what Jocelyn just said. She's using what we call the undistributing technique. How do we do it? So whenever you come across a case like this, and you want to combine the two like variables into one, I first identify the like variable. I cross them out completely, and what's left over? B plus C. You see that? Now, I group the B plus C together and place that variable that I just crossed out right outside of it. This is what we're actually using distributed but backwards in a sense. You see that? You see that? Because if you take the x and distribute again, don't you have bx plus cx? The same thing. But when we do something like this, it allows us to have just one x, and then we'll have wz minus 3a on the other side. Now how do I get rid of b plus c as a group? There, because it's linking by a multiplication sign. B plus c, b plus c, done. X now equals to wz minus 3a over b plus c. And this is how we solve for a specific variable with, variables in each side. Yes, great. Okay, so now you asked me, so what's up with this? Why do you have to even use this in real life? Are we gonna ever use this in real life? Okay, for most cases, for example, if you're gonna be just working at a fast food restaurant or anything like that, yeah, of course you're not gonna use it, right? But if you ever go into an engineering field or whatever it is that you have to use for, and if you're gonna start calculating, for example, let me give you a formula. What's this? What formula is that? Above?
Here.
Sphere? Okay. Volume of a cylinder. But if you are an engineer, you're not going to look at it just one way. You don't ever look at it and say, so this is the only thing I use if I want to use to find a volume. Not the case. Because now if you know how to solve for a specific variable, you can also solve for R. You can also solve for H. Because sometimes what if the only thing I give you is, okay, I have this volume, but I don't know the dimension of this. Can you measure what the radius is? What if we have no access to the cylinder? It's like deep underground, but the only information we have is I have the volume of that. See, then don't you need to actually go back here and solve for the radius? How do I solve for r? Do I need to get rid of pi and h? So that's why we want to solve for a specific variable that we want. There it is. Okay, so practice it. We have a group quiz tomorrow. Please study.
Passes our head.